Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give a practical example related to the application of Friedman test. And here we have the problem of assessing the effect of different amounts of cobalt on the tensile strength of steel. So here we are talking about different treatments or different conditions that are given to our sample, and we would like to measure the tensile strength of steel. Here the treatment consisted of 4 different levels expressed as the percentage of cobalt and the 8 crucibles in which the alloying process took place served as the blocks. So the blocks here is the 8 crucibles given here. So these are all the blocks. The tensile strength in thousands of psi of the resulting 32 specimens of steel are shown in the table. Can the null hypothesis of no treatment difference be rejected at 10% significance level? Okay, well, again, I hope you are able to see that the data from treatment A, treatment B, treatment C, and treatment D, all these data came from the same subject. So here is the same block. Similarly, this one, this one, this one, and this one, they came from this particular block. So those values here are dependent, okay, because they all came from the same particular source. Okay, so that's the idea of dependent sample. So even though we have at one glance we see 4 different groups, but they are actually 4 dependent samples. Okay, right, having said that, let's start off with the first step of the data analysis here. So the first step is writing down the hypothesis statements. Again, you can use the structured way of writing the hypothesis statements as I have discussed in the previous video. So here we go. Step 1. For H null, there is no difference in whatever the question is asking you to find, to do, to measure. There is no difference in the tensile strength of steel. Okay, in the tensile strength of steel across all groups. So when you, or in other words, there is no difference in the tensile strength of steel when different treatments are applied. So what are the treatments? The treatments are this one. They are different because they use different percentage of cobalt. Okay. Now for the alternative hypothesis, the way you can structure it is that the tensile strength of steel, the tensile strength of steel is different in at least one group. Okay, so those are the hypothesis statements. The keywords here: no difference for all groups, different at least one group, and over here is the whatever the question is asking you to find, or whatever the data is all about. The data here is about the tensile strength of steel. Okay, now we move on to the next step, which is to obtain the test statistic. And the first step related to it is to rank the observation first, and we will rank according to the first block. So here is the first block. The smallest one is this one, 1, and then 2, 44, 3, 4. Okay, next is 1, 2, 3, 4. Okay, and then 1, 2, 3, 4. Moving on, 1, 2, 3, 4. Next is 1, sorry, this is 1, 54, 56, 2, 56.6, 4. Alright, then here is 5, 1, 57.5, 2, 3, 4. Next is 1, 2, 3, 4. And then we will have 1, 2, 3, 4. So that is the ranking process. You do it according to blocks. Next is find the sum of ranks for each group, for all this group. Okay, so Ri 3, 6, 7, 10, 14. Okay, 7, 9, 11, 13, 14, 16, 19, 3, 4, 8, 11, 15, 19, 23, 27, 6, 11, 15, 20. So those are the sum of ranks for each group. Okay, so in the second step, we shall focus on obtaining the test statistic. The formula is given as such: 12 over n k plus 1. And here is the summation of the square of our Ri minus this guy. Okay, so just plug in the values that you have got. Our n is 8. The number of groups is 4, and here is 5. Over here is 14 squared, 19 squared, 27 and 20, minus, so you have to do the process here first, and then minus 3, 8 and 5. So put in all the values here in your calculator. You should be able to get the test statistic equals to 6.45. Okay, on the third step, we shall focus on finding the critical value. Again, this table here, chi-square distribution table, it can be used for a large value of n and large value of k. But if the sample is small or the k is small, then the table here gives an approximate value, not the exact one. So we'll just demonstrate how can you apply this table here to this particular example. And here, in order to find the critical value, you need to know what is alpha. Alpha is 0.1, 10%. What is degrees of freedom. Degrees of freedom is k minus 1. K is the number of groups. We have 4 groups, so 4 minus 1 is equal to 3. So go to 3 degrees of freedom. 0.1 is the significance level, and here is the critical value. Therefore, the critical value is 6.251. So in step 4, we will decide whether we should reject or do not reject the null hypothesis. Based on this, you can see that this is the critical value, 6.251. So 6.251 will give the critical region on this side here. And the test statistic that we have is actually 6.45, and the position of that is to the right of 6.251. It could be over here. So that means the test statistic falls into the critical region. Therefore, we are able to reject. Since 6.45 is greater than 6.251. So here is the test statistic, and here is the critical value. Okay, then we can focus on the last step, which is to conclude. At 10% significance level, there is enough evidence to say that the tensile strength of steel, okay, so basically this is just taking back or writing back the alternative statement. Enough evidence to say that the tensile strength of steel is different at least in one group. Okay, that's all for now. That's the end of this practical example. Thank you very much for watching.